right, hello again everybody, ready to start 2.6 Ionic naming. I'm going to go through this. First off, I'll say the video they've got here, since it's a Khan Academy video, I can't put it into my YouTube playlist. You can link it and watch it from here. So, you would just hit Control and click on it. It's about 4 minutes. It's a good rundown. Again, I might advise looking at it just so you can hear it and me and have two different ways of looking at the same problem, thinking about it. But I'm going to talk about how to do how to name ions and how to name ionic compounds, how to find the formulas of ionic compounds, and all of that right here. I might do it in a couple of different parts. So first video, I'm going to focus on naming ions. So this is just the first part of this worksheet. So monatomic ions. So monatomic ions are ions made of monatomic. Mon means one, so one atom. There are also polyatomic ions, ions made up of more than one atom, but we're not going to worry about those. We're not going to do those. We're just going to focus on monatomic ions. So with monatomic ions, it's easy to determine the charge. It's something we've already done, right? So we've looked at things in group 1 that have one valence electron. They lose one, they become +1. Things in group 2, they lose 2 and become +2. Groups 3 through 12, what I will tell you is that they will form positive ions, but they're weird. So you don't have to worry about those transition ones right now. Okay? Group 13, so the boron group, they lose 3 electrons to form a +3 ion. Group 14, for most of these, carbon and silicon do not form ions. For the rest of the group, you must be given the charge. So I'm not really going to have ones from group 4 for me. I'll be honest. Group 5, they gain 3 electrons and form a -3 charge because they have 5 valence electrons. They need 3 more to get to 8, right? Group 16, they have 6 valence electrons, so they need 2 more to get to 8, so they have a -2 charge. Group 17, they have 7 valence electrons. They gain 1 more to get to 8, and they have a -1 charge. So if you're ever looking at it, it's kind of like this, right? So you've got, these are +1, these are +2, these are +3. These we're not really going to deal with in ionic bonding. These are -3, these are -2, these are -1, and then finally these ones don't form ions because they've already got a full valence level, right? Okay. So, coming back here, when we're going to name the ions, it's really, really simple. If you have a cation ion, which is a positive ion, an anion is a negative ion. I forgot to go over this. Here are 2 ways that are really good to remember. Way number 1, I like cats. Cats make me feel all positive. Onions make me cry. Anion looks like onion. So you can think of it. Cats are positive, onions negative. That's a really silly way to remember it, but it's one of those things that no matter how ridiculous I thought that was when I learned that in school, it has stuck with me for so many years, and it's ridiculous. The other way you can think about it is if you look at these words, cation and anion, only one of them has a plus sign in it. If I were to write this out, I could know right now if I'm going to write cation, Ca+, cation has a positive sign in it. So cations are positive. That's how I would think about it. I'm going to erase that right now and go back. So remember, cation's positive, anion's negative. All right, so simple cations named by saying the element and adding the word ion. So, for example, Na+ is a sodium ion. Mg2+ is a magnesium ion. Super easy to name. If you're naming it, it's sodium ion, magnesium ion, lithium ion, zinc ion, aluminum ion, boron ion. Really, really easy. Anions, the negative one, the onions that make me cry. Negative. Doesn't have a positive sign on it. It's negative. They're named by dropping the ending off the element and adding "-ide." Usually you're just going to do one syllable. In fact, there's really only one I can think of that you don't just do the first syllable. So instead of fluorine, it's fluoride. Instead of oxygen, it's oxide. Instead of nitrogen, it's nitride. Now there are a couple that require more than the first syllable, but honestly, if you're trying, well, I'll tell you what they are. Selenium becomes selenide, and iodine becomes iodide. So it's not just ide or seide, cellide or something like that. Selenide and iodide. You know, and that's the way it's going to go. So basically, when we're looking at these, we're going to take a look through. We're going to look at what is the element symbol for sodium. So I'm going to find that on the periodic table. This is not the greatest periodic table. I just happen to know it. So sodium, Na. My ion name for it would be a sodium ion, because I know if it's in this column, it's going to be a +1 charge. So my formula for it is going to be Na. And remember, you can do the superscript by coming here and clicking on that. And I can do a plus because it's a +1, or if I want to do a 1+. Either way works. So then bromine. We're going to go find bromine real quick. Right here, bromine. That means it's in this column, which means it's going to be a -1 charge. So my symbol for it is Br. When I go to write the name, it's bromide. Now, one thing I hate about Word is that it always, when you hit a space on the first letter, it always wants to capitalize for you. You don't need to capitalize the names of elements or the names of compounds. They're not proper nouns. You only need to capitalize the first letter in the atomic symbol. All right, so for this one, again, Br, come up to the superscript. I can do a minus, or I can do a 1-. It always likes to do that to me. 1-. So there we are with that. That's what we're thinking about with this table, filling it out all the way down through helium. I will give you one other hint. I'm going to come down here and I'm going to look at number 8, neon. So I'm going to come find that on the periodic table. Ne, it's right here. Okay, that one's weird because I know these are +1, +2, +3, not really forming ions, -3, -2, -1, not really forming ions. So with something like this, it's Ne for the symbol, but it doesn't form an ion. So I can say something like no ion, or not applicable if you want. So think about that as you're going through. There are some questions in here that are kind of trick questions. This one's not really going to form an ion. I want you to be able to identify the ones that are not necessarily going to form an ion. All right. That's all I've got for this. I will pause this here, and then I'm going to put up another video for talking about the part 2 of this simple binary ionic compounds. All right, back in a minute.